Hi guys, this is Mrs. Lyons. Today we're going to talk about balancing chemical equations. And when we balance chemical equations, typically our equation is given to us. It's our reactants, and then an arrow, which means yield, and then our products. And the only thing that we can change to make our equation balance is the coefficient in front of the element or compound. We can't change the subscripts. We can't just add random elements. We have to change it in a manner that we're only changing the coefficient. And our overall goal is to follow the law of conservation of matter in getting the same number of atoms of each element on the same side, each side of the arrow, okay, each side of the equation. So I'm going to give you a couple of strategies for solving balancing chemical equations. The first one is going to be the dot method. And to do that, we're going to use different colored dots to represent each element. So in this case, I'm going to use a reddish orange dot to represent sodium, and I'm going to use a bright blue dot to represent each chlorine atom. So what I'm going to do is I'm going to look at my reactant side of the equation. I've got a Cl2. I'm going to draw that Cl2 in just dots. So I've got 2 chlorines, so 2 blue dots. Over here on the product side, I have NaCl, sodium chloride, so that's 1 blue for the chlorine. And then, like I said, I'm going to use these red dots to represent sodium. For sodium chloride, I've got 1 red, 1 blue, 1 sodium atom, 1 chlorine. On the reactant side, I've got a single sodium. Now, as I balance, my goal is going to be to get the same number of colored dots on each side of my reaction arrow. So if we start out and we count, I have 1 red dot in my reactants, 1 red dot in my products. So it looks like, okay, my sodium looks good. But if we count up my chlorine, I have 2 chlorines in my reactants. In my products, I only have 1 chlorine. So that's not going to work. Now, the only way that I can add chlorine is to add a whole piece. I can't just add a chlorine atom. I also have to add a sodium, because this is a sodium chloride. It's a compound. So as I'm adding a chlorine, I'm also adding a sodium. Okay, so now if we count, my chlorine is balanced, but now my sodium is off balance. I have 2 sodiums, 2 red dots on this side, only 1 on this side. So I can fix that pretty easily. I just add a second sodium. Now if we count, I have 2 red, 2 sodiums, 2 sodiums, 2 chlorine, 2 chlorine. So my equation is now balanced. So now it's just a matter of writing in the coefficients. And to write in the coefficients, I have to count. I used 1 sodium, 2 sodiums, so I'm going to put a 2 here. I only had 1 chlorine atom, so that coefficient is a 1. And then I had 1, 2 sodium chloride. So I have 2 sodium chloride. If I use coefficients 2, 1, and 2, my equation is balanced. Let's look at another example. Calcium plus oxygen reacts to give us calcium oxide. So again, I'm going to use the dot method. I'm going to use, for calcium, I'm going to use bright orange dots. So here I've got a calcium, here I've got a calcium. For oxygen, I'm going to use the blue dots. I'm making a little key down here so I know what's what. So here I have 2 oxygen. I have an O2 because remember that's one of those diatomic elements. And here I have calcium oxide. So I have a red and a blue together. So what is out of balance? If we look, I have 1 red on each side, but over here I have 2 blue, only 1 blue. So to start out, I need to add another blue. I can't just add a blue though. I have to add the whole molecule, so a whole calcium oxide. Now, if I look, I've got 2 blue on my product side, 2 blue on my reactant side, but now I have 2 red also, so I have to add a second calcium atom. Now everything is balanced, so I should be able to go put in my coefficients. So if we look, I had 1 calcium, I had 2 calcium atoms. Here I just had 1 O2, and then I had 1, 2 calcium oxide. So that gives me a balanced chemical equation. The next equation we're going to try, I'm going to show you a little bit different method for balancing this. And it's a method, another method that you may prefer, and it gets you away from the dots, which when we get into the more complicated ones is probably a good thing. And what I do is I use this arrow as the dividing point. That's the dividing point of my reaction. I've got reactants over here and products over here. And I know that that arrow sign is like an equal sign. So my reactants have to equal my products. I have to have the same number. So what I do is I just make a list of all of the elements in my reaction. So in my reaction I've got aluminum and I've got bromine. And I check that out. On the product side I also have aluminum and I have bromine. So how many aluminums do I have in my reactant side? Count them up. I've got 1 aluminum. How many bromines do I have on my reactant side? Br2, so that's 2 bromines. On my product side I count. I have 1 aluminum, and on this side I have 3 bromine. Okay, so this is just a tally of how many reactants and products I have. Now what I need to do is I'm going to kind of start playing around. I've got to figure out how would I balance this bromine. Okay, I've got 3 over here and 2 over here. This is a common thing you're going to see, and when you have this you need to look for a common factor. Okay, in this case, what number do 2 and 3 both go into? What's the lowest common multiple? And that would be 6, right? 3 goes into 6, 2 goes into 6. So we're going to try to get 6 bromines. So here I have 3. What number do I need to put in here as a coefficient to give me 6 bromines? 2, right? Because 2 times 3 is 6. So what I'm going to do is I'm going to now write down how this has changed my numbers of elements, of atoms in my product. So this 2 multiplies by everything. So now I have not 1 aluminum, but I have 2 aluminum. So I'm going to change this to 2. I also now have 2 times 3. I have 6 bromine. Okay, and we said we wanted to get to 6 bromine. Now we need to get to 6 bromine on this side of the equation. So what coefficient can we put in here to give me 6 bromine? Well, 2 times 3 is 6, right? So now I need to change this tally to show that I now have 6 bromine. So right now at this point, if you look, my bromine are equal. My aluminum are not balanced. I've got 2 aluminum in my product side. I've got 1 aluminum in my reactant side. So I need to add a coefficient in front of aluminum to give me 2. So if I put a 2 here, now I have 2 aluminum. So this is balanced. So this gives me a balanced chemical equation. Let's see if we've got one more. Sodium plus oxygen reacts to give us sodium oxide. So I'm going to make a list of my reactants and my products. I've got both sodium. I'm going to write reactants, products, and I know that they have to equal each other. Alright, I have 1 sodium in my reactants and I have 2 oxygen. Okay, over here I have 2 sodium, 1 oxygen. So this one starts out, they're both out of balance. So let's think about what, and it doesn't matter what order you do these in. So let's just start. I wrote sodium down first. So I have 2 sodium over here, only 1 over here. So what coefficient can I put here to give me 2 sodiums? If I put a 2 here, I now have 2 sodium, correct? Okay. Now I have 2 oxygen in my reactants, only 1 oxygen in my product. So I need to put a 2 here. Now notice what that does. does that, it changes, it gives me 2 sodium, but how many, or excuse me, 2 oxygen, but it also gives me how many sodium? It gives me 4 sodium. So all of a sudden my sodium aren't balanced. And that's okay. Sometimes you have to go back and forth a couple of times because we can balance this. Okay, our oxygen, we have 2 on each side. Now we have 4 sodium in our products, 2 sodium in our reactants. How can I get this to be 4? Well, I just changed that coefficient to 4. Now I have 4 sodium. So my balanced equation is 4Na plus 1O2 yields 2Na2O. And that gives me a balanced chemical equation. One more. And this one may seem a little bit complicated because we've got a whole lot of elements in it. But this, I want you to think about the polyatomic ions. So we're going to do the same thing. We've got our reactants. We've got our products. We know they need to equal. So what have we got? We've got sodium. We've got aluminum. Now, we could write down that we've got nitrogen and oxygen, but I want you to notice something. That NO3, we've got an NO3 over here too, and that NO3 is one of those polyatomic ions. Anytime a polyatomic ion occurs on both sides of the equation, you can just keep it together and count up how many of them there are. You don't have to break it down into the individual elements. So let's count. We've got 1 sodium, 1 aluminum, 3, because the 3 is outside of the parentheses, so 3 nitrates. Over here we have 1 aluminum, 1 sodium, 1 nitrate. Okay? So what coefficient can we put in front here so that we have 3 nitrates? A 3, right? So that gives us 3 times 1, 3 NO3s. But also we have to remember it changes our sodium. It gives us 3 sodium. Now we have to go back and we have to put a 3 here to balance our equation so that now we've got 3 sodium, 1 aluminum, 3 nitrates. If you want to put the 1s in, you can. It's not always necessary. So hopefully that has given you a little help and a little guidance on balancing chemical equations. There's lots of practice on Haiku, so take a look at that and I will see you in class.